Okay. Are there more children diagnosed with autism in states that have larger urban areas over states that are mostly rural? In Pennsylvania, an urban state, there are 245 8-year-olds out of 1844. So we're going to go, the proportion in Pennsylvania is equal to 245 out of 18,440. So that's really small. What do we have? 245 out of 18,440, which gives us 0.013. So 1.3% of the 8-year-olds are on the autism spectral disorder. So then the proportion in Utah is equal to 45 out of 2123. So 45 out of 2,123 is 0.02. So that looks higher. 0.021. Okay. So 2% versus 1%. So the question is that statistically significantly different? So is there enough evidence to show that the proportion of children diagnosed in Pennsylvania is more than the proportion in Utah? No. Clearly not. That's odd. Did I type that in wrong? 45 out of 18,440. That's 45 out of 18,440. Oh, 245. So that's 1.3%, and this is 45 out of 2123. 2%. So that's clearly smaller than that. So is there enough evidence to show that the proportion of children diagnosed with in Pennsylvania is more? No. Okay. Well, the answer to this is clearly going to be no. This looks like it's smaller than that, so I'm not going to have any evidence to suggest that this is going to be larger. But they told us to do the test. So what are we doing? We're going to say the proportion in... So let's see. Our null hypothesis is that the proportion in Pennsylvania is the same as the proportion in Utah. The alternative hypothesis is the proportion in Pennsylvania is greater than the proportion in Utah. So we're going to be doing a two-proportion test, and it's going to be one-tailed. We can clearly see that this is going to come out to be not enough evidence to reject the null, because this is obviously on the wrong side of the distribution. But we'll go ahead and do the formula. So our z-score is subtract the two. So we're going to go p hat in Pennsylvania minus p hat in Utah divided by the square root of 1 over n sub p plus 1 over n sub u times p combined, q combined. Okay, so now we need, and remember your book calls that p bar, q bar. I just call it the combined proportions. So we're going to go p combined is 245 plus 45 out of 18,440 plus 2,123. So let's figure out what that is. 245 plus 45 divided by 18,440 plus 2,123 is 0.014. Okay, so now we have enough information to fill in the blanks. So this is going to be our 0.013 minus 0.021 divided by 1 over 18,440 plus 1 over 2,123, and this is all underneath the square root, and then this is going to be times 0.014, so it's p bar and q bar, and so that's going to be 1 minus 0.014. So what is that? 98.6%. Okay, so there's the formula. So now let's just go ahead and let the calculator do the rest of the work, because I don't want to type all that stuff in. So we're going to go stat test two proportion z-test. And what do I have? I've got 245 out of 18,440. And then this one is 45 out of 2123. And we're testing to see whether or not the first one is smaller than the second one. I'm sorry, bigger than the second one. We should be doing that it's smaller, but that's not the way the problem was worded. So then we will calculate it. And we've got a negative z-score with a very high p-value, right? So our z-score is equal to negative 2.926, and the probability that our z-score is as big or bigger than negative 2.926 is approximately 0.998. So we have no evidence to reject the null. It, in fact, appears the autism rate is lower in Pennsylvania, not